All right, finding zeros, finding real zeros of polynomial functions is really a process that involves us determining something by using a set of rules. And one of the most important rules that we have here in this entire section is the one that tells us something about the relationship between real zeros, x-intercepts, and factors of a polynomial function. So right here in the box is that statement, and this is also found in your textbook. Specifically, if you look at page 278, you'll find it there. Page 278. This is a very important idea to get in your mind. It says that if a polynomial function p, and if you have a polynomial function p and c is some real number, then all of these following statements are equivalent to one another in this sense. If any one of these statements is true, then all of them are true. Or if any one of them is false, all of them are false. And those statements are this: x minus c is a factor of f of x, of p. Pardon me. Let's go with p here. We've got a factor of p. X equals c is a real solution of the equation p of x equals 0. X equals c is also considered a real zero of the function p of x. And that's equivalent to saying that c0 is an x-intercept of that polynomial. So what does that mean? Well, let's take a look and categorize this information using the function y equals x cubed minus 2x squared minus 5x plus 6, which I've helpfully graphed off to the right here for you already. Well, what could we say? If we look at this graph, we notice that the graph is passing through the x-axis at negative 2, 0, 1, 0, and 3, 0. So in other words, if we take a point like x equals negative 2, the point negative 2, 0 is an x-intercept. What else could we say? Well, then we could also state that x equals negative 2 is a 0 of this function y equals x cubed minus 2x squared minus 5x plus 6. What else could we say? Well, x equals 2, x equals negative 2 is a solution to the equation x cubed minus 2x squared minus 5x plus 6 is equal to 0. And not only that, one other thing tells us that x minus negative 2, that is x plus 2, is a factor of our polynomial y equals x cubed minus 2x squared, x cubed minus 2x squared minus 5x plus 6. Now, all of these things can be said at x equals 1, which is a 0 of the function, and also at x equals 3, which is a 0 of the function. Since they are x-intercepts, they are zeros of the functions, and x minus 1 and x minus 3 would be factors of our polynomial function. As a matter of fact, we can actually verify that right here in sort of an interesting way. If we know that x plus 2 is a factor of this polynomial function, let's relate it back to something that we already know. That is, the zero factor theorem tells us that if we have a factor, the remainder of our synthetic division should be equal to 0, and we can rewrite the function as a set of linear factors with x plus 2 as one of those factors. Let me show you. Let's take negative 2 and let's set that up in our synthetic division with our leading coefficient of 1, negative 2 as our x squared, coefficient, -5 as our x coefficient, and 6 as our constant term. All right, what do? Carry down the 1. Multiply it by -2. Add going down the column. Multiply the two terms, so we get 8. 8 minus 5 is 3. Multiply -2 times 3 to get -6. That gives us our remainder of 0. And we can actually state that y is the factor x plus 2, the divisor, times x squared minus 4x plus 3. And sort of the nice thing to see right here is that once we realize that fact, well, lo and behold, we now have a polynomial that we can factor even further, right? X plus 2 would be multiplied by the pair of factors that make up x squared minus 4x plus 3, which is to say x minus 1 times x minus 3, which fits very nicely with the fact that we know that x equals -2 is a 0, x equals 1 is a 0, and x equals 3 is a 0 when we set the equation equal to 0 itself. Useful information. All right, more to come.